Okay, in this video we will solve this problem right here where we want to know the bubble point pressure of the mixture where we have a ternary mixture and the vapor composition that results. So let's look at the problem. So we have compound A, compound B, compound C. The mixture obeys Raoult's law and the molar composition is XA is equal to 0.5 for compound A, XB is equal to 0.4 for compound B, and XC is equal to 0.1 for compound C. And at temperature 65 degrees Celsius, vapor pressure, PA-SAT, is 2.5 bars for compound A, 1.25 bar for compound B, and 0.5 bar for compound C. And so we want to know what is the bubble point pressure of the mixture and the vapor composition that results. Whenever we're doing bubble point pressure for ternary mixture, quaternary mixture, formula is something like this. And so in this problem, we want to solve for bubble point pressure. So the only thing that's missing is P, our pressure. And so in this case, when you solve for P, that will be our bubble point pressure. And so let's do that. So we know XA is 0.5, and we know PA VAP is going to be our 2.5 bar for saturation. So 2.5 bar. And we don't know P, so divided by P. So plus, now we do the same thing, XB bar, so 0.4 times 1.25 bar divided by P plus 0.1 times 0.5 bar divided by P, and this whole thing will equal 1. Okay, so in order to solve this problem in Excel, we have to do a few things. First, the way we're going to really solve this is by kind of guessing what our P will ultimately be. And I'll show you what I mean. So let's just write this down. P variable, and then we have YA, YB, YC, and we know that YA plus YB plus YC will equal 1. So 1 right here. And now we will kind of generate and propagate our P term. So we'll first say 1, then we'll say 1.05. They're pretty close to each other. And I'll just simply hit the crosshair and go down all the way to 2. I think 2 should be reasonable. If it doesn't work, we can always add more numbers. We can make it more narrow, etc. So then we'll do YA. So we can say equal parentheses. YA is XA times PA VAP divided by P. So we know XA is 0.5 times 2.5, close parentheses, divided by our P term. Hit enter, and then hit this crosshair here and go down. Next we'll do YB, same procedure. So we will say 0.4 times 1.25, close parentheses, divided by our P term, hit enter, and simply drag and drop. Next, YC, equal parentheses, 0.1 times 0.5, close parentheses, divided by our P term, hit enter, and simply drag and drop. And now we'll sum, so we can hit equal sum, parentheses, these pieces right here, YA, YB, YC, close parentheses, enter, and now simply drag and drop. Wait, let me go back. This is sum. So we need to see where does a sum equal 1? And it equals 1 right here when P is 1.8. So our P bubble will be 1.8 bars. So we can say P bubble will be 1.8 bars. We're looking for what is the bubble point pressure of the mixture, which we just solved. Now we want to know the vapor composition that results. So we want to know YA, YB, YC. Pretty simple. And so YA is going to be like this, XA times PA VAP divided by P, and YB will be something very similar. So let's first solve for YA. And so do we know XA? We know all of this. We're simply solving for this piece here. So we would get 0.5 times 2.5 bars divided by 1.8 bar. and this right here will equal 0.6944. This is for YA. Next we'll solve for YB. Very similar. So YB is equal to this piece right here. So 0.4 times 1.25 bars divided by P, which is 1.8 bar. And so we would get 0.2778. And the last one, we can do two things. Because we know that YA, YB, and YC will ultimately equal 1, we can simply do 1 minus this piece, or we could do what we did normally, where we just do 0.1 times 0.5 divided by 1.8. I will do the first way, where we say 1 minus 0.6944 minus 0.2778, and so we would get 0.0278, and this right here will be YC. And that's all we need to do for this problem.